morning. My name is Dick Cicchini. I will be the presenter for the Falcon USS presentation today. With me is Ted Sturm. He is my wingman. He will be helping me in this presentation. People who've attended before have heard this. We have all of the attendees muted. The reason that we do that is we get feedback, noise, background conversations, and so forth that detract from the presentation. However, you can still ask questions at any time by raising your hand and using chat. And we encourage you to do that at any point within the presentation, and Ted will interrupt my presentation. There's be a nicer word than interrupt, but interject, and ask those questions on a slide-by-slide basis. And at the very end of the presentation, we have a pause just for questions, again, to go back, or if you're making notes and you didn't want to interrupt. But please feel free to interject and use chat to get those questions to Ted. So here we are, Falcon USS, our beginning slide. The first thing, before I even go into product description, let me get my screen working correctly. The Falcon USS product is a finalist for Outstanding Security Hardware Product of the Year. We're crossing our fingers that we become the actual winner of the product, but it's quite an honor, and it goes to the technical capabilities of this product just to be nominated. There's a lot of good competition out there, as you're aware, if you're using, shopping, or reselling. And we, of course, will follow up. If you never hear from us, we were just a finalist, but rest assured you'll get press announcements if we win the award. And I'd like to say when we win the award. The things we'll be covering today about the Falcon USS, we're going to ask first the basic question of virtualization. Why? What does it buy you? We're going to go into virtual server basics so that you can understand how it works at an elementary level, but still give you the concept to understand what's happening. We're going to do a server overview, the physical attributes and features and product that comes standard inside of it. And then we're going to talk a little bit about the correct application of virtual serving. And then we're going to talk about storage with the Falcon USS, and then next shared storage, and last as a combination of the server capabilities, the virtual server capabilities, and the shared storage capabilities, how that affects the ability for you to enact a high availability configuration. And as I mentioned earlier, at the very end, time for general questions or specific questions. If they're too specific to this presentation, some of those we'd like to follow up with more highly concentrated answers that you probably are looking for that other people might not care about. Okay, first question is, why virtualization? Virtualization actually is technology that's migrating into the security space from IT. What happened as IT was changing, and there's a migration to Windows-based and Linux-based Intel machines from the old status quo of STI proprietary architectures, Sun proprietary SPARC architectures, IBM and so forth, it was less expensive to move to an Intel Windows platform. But what happened was these servers, you would have all of these 1U and 2U servers that were doing one thing. They were singularly tasked. So that you had an Exchange server, you had a SQL server, you had another machine that was an application server. And in so many cases, what had happened from what was old, and you could barely get an Exchange server to run in some of the earlier Xeon and P4 processes, the new servers are coming with these Xeon processors with, 2-3 gigahertz of clocking power, and you couldn't buy the old small processors. So you had machines that were severely underutilized. Some of the examples here, Exchange servers running at 30% of what they could actually do, file servers at 35%. So you were buying a product that was capable of so much more. So along comes virtualization of virtual OS technologies that allow you to take these different functions that require that they run in their own server space and combine them and use them in one machine. So now instead of a machine sitting there 80% of the time idle, you can run 4 virtual servers in a single physical server, which of course for your money you're paying for that machine, but it's doing 4 different tasks that it couldn't do before. The other issue that you had was you had 4 servers. You didn't have, from Microsoft, you didn't have single management panes where you could look at everything at one time and see what was happening, what memory resources were being used, what were problems. So it was more difficult to manage this. And they came out with the consequent term server sprawl, where you just had scads of servers and you had no way to manage them other than individually, which of course is very inefficient and ran your manpower out. So a combination of reduced management, ease of management, and tasking a single server rather than 4 servers, you were reducing your costs. All of this goes to giving you a poor return on your investment. So now we virtualize, and we can take 4 of these servers, combine them into one. We're utilizing these things to the maximum. We've got single management screens, and now virtualization brings about a new feature. Now we can create high availability for all applications. I shouldn't say all, but for qualified applications. High availability before was limited to SQL database clusters, Exchange clusters, and only those applications that were designed by Microsoft to fail over and create high availability were supported. Virtualization opens the door for security applications, and we're security centric here, but as a side, Word applications or Joe's sizing tools and so forth. So virtualization is going to give us the ability with correct configuration and so forth to create a high availability, no downtime. You would never notice that a server failed. It's transparent to you. So virtualization can provide superior return on investment through manpower, training, cost of equipment that has to be applied for your overall objectives. And again, just a screen I wanted to demonstrate here. Now I've modified that other screen to put something in perspective that's more germane to you. NVRs that have 16 camera support, they're sitting there loafing at 30%. Intrusion alarm software running at 35, client management, and then a secondary NVR software package running at 8 cameras. Again, we have machines here that are sitting there running between 85 and 65% idle time. No I/O, no CPU, just sitting there. Now we virtualize it, and in this example, I had enough overhead and so forth that I could capitalize on a single box looking like 4 servers and running 4 distinct tasks. Again, ease of management, superior ROI. How does this work? On the left-hand side, and I drew it in a block, and I'll touch on it. You had a CPU. Maybe you had 4 cores in it, right? And you had memory, you had NIC ports, you had storage I/O, and the OS ran inside of this box, and the application was later on top of the OS. Single box, single task, and again, we called the question, how much was that being used? I do want to make a point right now. This configuration of single servers doing single things, a single server dedicated to running the VMS and camera video and recording. it still has its place. Where in the name of the game is wherever you can, you want to maximize your camera support. And subsequently, if you maximize your camera support, that means you're going to be using all of the CPU, memory, and I/O resources in the best fashion. And in that case, you have a maximum return on investment. It's doing exactly what it can, as much as it can. That's still a very valid configuration, and probably will come into play in the majority of your solutions that you present to your customers. However, let's move over to the right-hand side where we now have virtualized a system. Now, it varies, it changes a little bit. Some of the basic components are still there. You'll notice I still have CPU, memory, application, but what I've done in the middle, let me see if I can get a pointer up here. In the middle, right here, I've interjected a virtual operating system. When the server comes up, it boots to the virtual operating system. It no longer boots to Windows or Linux directly. So the virtual operating system comes up, and the virtual operating system, it's in charge of CPUs. How much of a CPU or a core does it apportion to a specific task? In this one, I could say it's a quad-core processor, and it's going to give one core to this machine, this application, one to this, and one to that. And that's a simplistic way to understand how virtualization can optimize your CPU efficiency. And we'll touch a little bit more on how it differs from that later in the presentation. The virtual operating system not only presents CPU power to each of these segments, it also allocates memory. It takes care of I/O traffic in a guest OS and runs it through and to the physical NIC port layer. And the virtual operating system also takes care of storage. So if you have in this case we're talking single boxes, that's the Falcon USS architecture. It has a single hardware-based RAID controller with a number of disks that gives you X amount of storage, 16 terabytes. Right? The virtual operating system will carve this space up by setup and by balancing measures and present different amounts of storage to each of the OSs and applications as required. It's not a fixed number. It's not going to be divided by 4, so each of these segments gets 4 gig. It can change. If this required 2, that's what it would present. If this requires 8, this is all part of the setup and configuration of the virtual OS. But the key thing to understand is when you virtualize, it's this layer, this operating system, that is in control of everything. It's memory, all resources, as well as balancing or following policy set with regard to who gets what. A couple of the key things that we use so we all talk the same. Here I have an application and I have an OS. These become represented as application and guest OS. So when I talk, I say this is a guest OS, and we'll have 2 guest OSs. One guest OS is going to be running a NVR software package. Another guest OS would be running an intrusion alarms package. So the correct term when we talk about how many virtual servers we have, those reside in each of the guest OSs. So in this case, I have 4 guest OSs and I have 4 virtual servers. Quick technical physical overview of the Falcon USS. The Falcon USS comes in 2 versions. The first is a 3U product, and it supports up to 16 drives internally. These can be mix and match depending on the application's requirements. It can be all SAS 15K, and that's SAS 6G. That's the 600 gig, the latest and greatest interface that's available for I/O. And it can also be all SATA drives, SATA 3 or SATA 2 drives, or it can be a mix and match where you need high performance for the application and buffering of video data, we can put in 2, 3, 4. We can adjust the balance between SAS drives for performance and SATA drives for general video storage. Now, what's really important here is when we'll get a little bit more into this, both of the Falcons come standard with a 2.4 gigahertz quad-core Xeon. This is the 4th or 5th generation of the product, and it also supports up to two processors. The standard is a quad, but we also have available for compute-intense environments 6-core processors. So you can have up to 12 cores of processing power available within the Falcon structure. Let me back up. I earlier mentioned I had a 1600 was a 3U 8 or 16 drive configuration, and the 2400 is a larger chassis. It's a 4U chassis, and it supports up to 24 drives. Again, mix or match, SAS 6G, SATA 2 or SATA 3 drives. In terms of getting it in and out of the box, this is always a big concern. What's my camera bandwidth? The product comes standard with 2 1 gig ports. We can pop that to 8 1 gig ports. I don't think any of you will ever need this, but we do have the availability to support up to 4 10 gig ports. I imagine there are some 16 megapixel cameras and 8 megapixel cameras. If they are running in MPEG mode, you might need that kind of bandwidth, but generally speaking, we don't see that in a single server configuration. We've talked about drives mix and match. It does come standard, both of them, with a DVD plus minus RW drive for backup, software loading, and so forth. And of course, the general numbers of USB ports and PS2 ports, serial ports, and so forth. The USB port actually we use with our quick recovery options that we have for all of our servers. And I don't have this down here. I'm sorry, I apologize. Both boxes come with 1200 watt redundant hot swap power supplies, and you have your choice of guest OS. In addition to the virtual OS, you have a choice of an additional guest OS of Windows Server 2008 R2, 64-bit, Windows 7 Pro, or Linux. And one more thing, just to go speak to the reliability of this product, we have redundant hot swap power supplies. Our RAID controllers come with battery backup for the cache, and of course you get your customary data protection with choice RAID 10, RAID 5, or RAID 6. So you can have up to 2 drives fail within a single RAID set and still chug. All right, virtual services or virtual OSs it's not magic. For the same reason that you're familiar with restrictions on how many cameras you can support or how many FPS you can support, or you have bandwidth restrictions with all of the VMS software products that are out there. You still have those types of restrictions that apply to this machine. So if you had a single machine that wasn't virtualized in NVR and it was maximized with 64 cameras and that was the maximum allowed on that server, and you came over and you configured our Falcon USS with a single core processor, and matched the configuration at a hardware level, it wouldn't work. There are certain resources that are automatically consumed. The virtual OS consumes a certain amount of CPU power, and it consumes about 1 gig of memory just to run. So automatically you have to detract that. So I'm not trying to detract from the virtual services. I'm trying to make you cognizant that you have to size your products correctly or you're going to have problems. You have 4 services or resources that you have to be mindful of when you configure. You have processing power, memory use, network bandwidth, and I/O bandwidth. If any of these resources individually or together or in conjunction with different resources is exhausted, then you need to revisit your configuration and see what you need to do to fix the problem. Touch on that in a minute. Good guidelines. And these are good guidelines in the general sense in a lot of cases. Leave a minimum of 10% reserved for CPU power and memory resources. So if your application says I need a minimum of 2 gigabytes, right away you know you need 1 gig for the virtual operating system, you need 2 gig for this application, and you really should, you can't do a pop to 3.3 meg. You're going to have to go up to 4, or actually you have to go to 6. You need to leave a small reserve in there for things that happen during peak periods and so forth. Leave a minimum of a 30% reserve for network and I/O bandwidth. The network, if we talk 1 gig or 100 megabits, whatever we want to look at, the old rule was, and we'll use 1 gig as an example. If you're in a 1 gig environment, that means you have a bandwidth of about 125 megabits per second, or bytes per second. That's as fast as you can move bits and bytes across there. The problem we have is within that bandwidth, the protocol, TCP/IP protocol, or UDP, it needs a certain amount of handshaking. There's information that has to go back and forth by protocol to say, I'm talking to you, here's what you're going to get. So that takes up a certain portion of the bandwidth. A good reduction for any network manager is, at a minimum, you will make a 20% allowance for this overhead that's always there within the network. Some people subscribe to 30 right away. I'm adding another 10% onto a general statement of 20 that's going to allow for burstiness of your cameras and backside if you're using external storage resources. Again, there's a certain, you might be running consistently at 40 megabytes per second, and then all of a sudden you're going to burst out for a stream of data at 80 megabytes per second. So make a 30% allowance on your I/O bandwidth and your network bandwidth. Touched on the virtual OS. It does require about the equivalent of 2 1.5 gigahertz cores. And roughly, as a general statement, 10% of what you're doing. And you say, well, how can that be? With different applications and different CPUs. The technology moves and the CPU availability, best price point, and so forth, seems to scale with this, and so there's a good 10 to 15% always seems to be the case as you're moving. Technology increases, application resource requirements increase. So, again, look at 10% or calculate, as we'll see later, 2 cores at 1.5 gigahertz each. We'll use about 1 gig of memory for the OS, so again, remember that. Okay, when you're using servers that have direct attached storage and are configured for high availability, automatically double the network storage traffic. All right? And all I'm trying to do here is to give you safety margins when you're configuring multiple applications within the Falcon USS. And these are universals. These are not DNF security, Dick Cicchini things. These are safe measures just as servers overall, but particularly you have to be mindful in a virtual environment. Okay.
Oh, Dick, I do have a question.
Yeah.
On the last slide, the bottom comment about doubling the network storage traffic, why would you do that?
I tell you, I have a slide a little bit further back, and I'd like to defer the answer to this question until we get to that section, and I'll be able to show you very clearly why you have to make an allowance for doubling the network storage traffic, if that would be all right. And I'll remind the individual or all of you about this question when we get to that slide.
Okay, great, thank you.
here, before I gave you basic guidelines, now I'd like to show you just some examples of basic calculations so that you can understand and see how resources are moved up. I'd also like to add at this point, a lot of times you'll look at your requirement, you'll look at our Falcon, you'll be able to size it correctly. If you ever have questions, you need to bounce it off of somebody, feel free to call myself. You can get a hold of me through the general number. We also have a number of other support engineers that can take that call in the event that I'm busy. So always, if you have a question, call us. We'll help you size that puppy. I generally always review anything that comes in just to make sure that what we send out is what you intended to get. But in these situations, call us. That's one of the nice things about us. We're easy to get a hold of. Example 1. I've got the 32 1.3 megapixel cameras. I'm using H.264 compression, and the cameras are running at 15 FPS. And I've got a VMS of surveillance application that has a requirement of dual core 2.1 gigahertz and 1 terabyte of memory. This scenario that I'm depicting is a VMS specific manufacturer requirement in order to support those 32 cameras. And at the same time, you know, Mr. End User recognized that I've got intrusion detection 64 points. Do I have to buy another server just to handle that? And the software requirements for that software was just a single 2 gigahertz Celeron and 50 megabytes no second. I'm sorry, that is 50 megabytes per second. There isn't a memory requirement. I forgot to put that on there. I apologize. So the customer's saying, I got these two. Do I need to buy 2 new servers? And we can sit back, and what you do is you calculate power based on per core, how much it consumed. So if in this situation here, VMS required the 2 cores at 2.1 gigahertz per core. The unit that we have supplied here as a given machine has a quad-core 2.5 gigahertz Xeon processor in it. So there's 10 gigahertz available of processing power. Okay? So remember that number. If it was a quad-core 2 gigahertz, we would only have available 8 gigahertz of processor power. We don't offer 2 gigahertz, but as an example, demonstrating how you would get the total power that the CPU has. The virtual operating system, remember, that uses 2 cores worth of power at 1.5 gigahertz each, and it requires 1 gig of memory. So I have 3 gigahertz of processing power that's required. And now the VMS requires 2 cores at 2.1 gigahertz each, so that's another 4.2. I'm now at 7.2 gigahertz of processing power. And the intrusion, pardon the quick abbreviation, required 1 core at 2 gigahertz. Right? So now I'm at 9.2 gigahertz. I have 10 gigahertz worth of processing power. Did I make it? I did. I also would like to say, by the hair of my chinny chin chin, and I had to break my rules about a 10% CPU allowance. I had a total memory requirement of 2.5 gigahertz, and I am well under the 2 gig, and I'm underneath the 10% allowance. In this particular case, it's so close, 9.2 versus a 9 with the 10% reserve. I probably would let this pass. I might want to talk a little bit more with the end user about his infrastructure, you know, what percentage of motion you do, trying to qualify it a little bit more before I would pop it up to a higher level of processor or adding in a second CPU. Quick calculations on this showed, and I'm not showing my supporting homework here, but I know that I was running at about 65 megabits per second bandwidth to support the cameras and the given to me for the intrusion software was I had to allow for 50 megabits, not bytes, per second. So I have 125 megabits per second allowance out of 1,000. I'm well under that 30% I/O threshold that we talked about earlier. This is a good configuration. This works. Let's take example number 2.
Dick, I have a question.
Yeah.
What happens if you exceed any of those resources?
The same thing that happens when you exceed resources on a regular server. If you had a single server running a VMS and you were clocked under, or you can't process the information fast enough, you would start to get frame drops. Now, it's a little different under virtual services. Remember, you have a virtual OS that's trying to do more. That would be considered a normal case. It would look the same. You're going to get frame drops, and you're not going to record all of your data. You might miss a window point where the intrusion detection software is alerted, and the processor was bound up doing something else, and it didn't process in time the other thing, or the software reacts and says, I'm giving you an alarm, you're not acknowledging I'm getting an alarm, and then it goes into a software fail state. So it's very important. Allow that overhead, size this product correctly. Like I say, it's not magic. If you take a pickup truck and you fill it up with 1 ton of lumber, everything's going to work fine if it's rated at 1 ton. But if you try to put another dump on it, it's mounted up and you have 2 tons in the truck, rest assured something's going to happen between the time you got the firewood and the place that you dropped it off. It's just not designed to handle the extra load. And that's why I'm going over this, is to make sure everybody understands this Falcon USS product is an outstanding product if you put it in the right environment. We wouldn't take that truck full of lumber and put it in the Indy race, would we? Different tasks, different things that it has to do. So let me move on to example number 2. Same camera load, same VMS that's handling the cameras, but now we've interjected, we need to provide for analytics. Now, it can be a plug-in, it can be a separate package, it can be a turn-on within that VMS software. But when you move and you start to do analytics from the easy license plate recognition up to facial recognition, field exclusions for motion and so forth, or obstructions, anything, it's going to require more power. I picked a metric of a medium scale analytic package running within the VMS. And it required a 2.16 gigahertz, and it could run separately as a server. It didn't have to be embedded in the same server. You consume 2.1 gigahertz, 4 cores of that, and it required just by itself another 4 gig of memory. Okay. Let's do the math. My virtual OS, I'm sitting at 3 gigahertz, 1 gig of memory. The VMS requirements to process the camera I/O, this is the same again. 2 cores at 2.1. I now have a 4.2 plus 3. I'm at 7.2. The analytics package, though, was 4 cores at 2.16 gigahertz. That gave me a total processing requirement of 15.84 gigahertz, more than 10. It also gave me a memory requirement of 6 gigabytes, certainly more than 3. My bandwidth was still okay. The analytics package was running within the machine, didn't use I/O, the network I/O, and there was significant bandwidth allowance for the disk I/O to handle referencing images and so forth. So I didn't have a bandwidth problem, but I did have a processing power. I did have a memory problem. Now, in the old school, you'd look at this and go, well, I guess I need a separate server. I have to peel out analytics and let it run on its own. Here's the beauty of the Falcon USS. I can resize it. I can add in a second quad-core processor, and I need to add 6 gig. There's certain memory increments that the Falcon grows its memory in. 3 and 6, 12, I think, are the increments that the USS can grow its memory. So while I only needed another 3 gig by virtue of the way the machine, the physical machine works, I had to add 6 gig. But adding a quad-core processor and adding 6 gig of memory is a lot less expensive than adding another server. So while you came up short in your initial calculations over a base unit, you still had an option. And I'm only adding a quad-core processor. There might be a situation where you would want to bump from a quad-core processor to a 6-core processor. There could be extremes where you would bump from the standard quad-core processor to dual 6-core processors. But again, this is a testament to the ability and flexibility of the Falcon USS to be grown within the box strictly at a memory and processing capability. Someone might say, you're out there, you're saying, well, what about network interface levels? You know what, we can accommodate you there. Come standard with 2 NIC cards. We can pump you up to 8 1 gig NIC cards. If we have to, we can move you into 10 gig. Call to question IO. I'll talk about that in just a couple of minutes. But the box is flexible, and you achieve savings and better return on investment, lower presentation, if you're a reseller, lower presentation of cost to your end users by just changing the box, not adding another complete server. That's the beauty, and that's the strength of virtualized servers.
Dick, I have a question here.
Yes.
Can the VirtualOS break up individual cores or CPUs?
Yes. That's one of the reasons. The way the VirtualOS works is it recognizes the individual cores. If you had a single core processor, obviously the single processor, but it looks at how many physical CPUs you have and the individual cores and the power available within each of the cores. So the VirtualOS can say, oh, you know what, I'm at 1, let's take the 2 cores here is a good example over here. The virtual operating system requires 2 cores at 1.5 gigahertz per core, right? Well, I have 2.5 gigahertz on a single core. So what the VirtualOS is, I will run within that 2.5 gigahertz. I still have a gigahertz left. It does not waste that gigahertz. It's going to take that 1 gigahertz and it's going to make it part of the processing solution for the next requirement, which is 2.1 gigahertz. So it's going to satisfy 1 gigahertz of that processing capability. It does, if you're going to manage it, you do have the ability to manually assign these values and restrict it so that while I only need 2 cores of 1.5, I could restrict 2 cores of 2.5 gigahertz to this. But it's better to let the VirtualOS do what it's supposed to do. Okay.
Great, thank you.
Okay, here's where we start to step ahead. We've already virtualized our product, and there's competition that virtualizes product. We like to think we do a better job at explaining and partnering so that bad things don't happen. But the next element within the Falcon USS that makes it unique is we have a technology that we use from one of our sister companies. It's called the SCVM. And it actually runs as a guest OS under the virtual operating system. And what it does, and you'll notice I still have 4 virtual servers. Once we add that SCVM, it should be 5 virtual servers. But what the SCVM does is it presents storage as IP SAN storage. And off the top you say, well, storage is storage. Do I need this? What's the matter with the RAID controller? here, giving and saying I have 16 terabytes of data, and the virtual OS, like you mentioned earlier, Dick, it carved that storage up between the guest OSs. Why do I want to take my storage and then present it as iSCSI or IP-SAN storage? Okay. Right now, if you look at this, and I excluded the comments on the bottom, there's no real advantage. However, what it does is it allows your internal storage to be presented as IP-SAN storage. And off the top, that means absolutely nothing to you, and it really has no value until I bring a little bit of a face towards it. Remember, IP-SAN storage is available to the SAN, to the iSCSI network. Right? Remember that. The SCVM allows additional servers to access Falcon USS storage. I'll show you in the next slide. Why is this important? How is it advantageous to you? First, we interject this SCVM. We take this storage pool. The guest OS says, oh, I'm going to apportion from an IP-SAN pool, not from the direct attached pool. Are they the same right now? Yes, in this drawing they are. And I'm going to apportion from this pool of storage here out to the different operating systems, right? And SCVM allows advanced features, such as mirroring, snapshots, optional replication, and then provisioning. But let me move on to the next slide, and I'll show you why all of a sudden it takes on a different light. Okay, I reduced the virtual server count just to make it a little simpler and cleaner. And remember now, this operating system thinks it's using IP-SAN storage. That IP-SAN storage is held in this software emulator, if you will, of iSCSI and IP-SAN storage. Remember, this storage is available to the network. SCVM now allows additional NVRs or servers tasked with analytics or client management to access this data that's held inside the Falcon USS exactly like it was IP-SAN storage, exactly like if it was one of our hardware products that we offer, our COX storage products. So now you're not adding in a box with extra storage and so forth. You can correctly size the USS product. Remember, it can hold up to 48 terabytes raw, or 44 terabytes in RAID 5 configuration, 42 terabytes in RAID 6 configuration. That's a significant amount of storage. So if you buy a product, you buy the Falcon USS with 12 drives, later you can expand it to 24, you can mix and match your drives. But now you're not faced with adding storage and storage enclosures. You can go with a 1U product that has compute power. These would be, in our world at DNF Security, VMEs. So you can add additional NVRs to the system without storage and take advantage of the storage that's available in the Falcon USS. You can also expand the storage. You can add on external IP-SAN devices, and the storage that is available here will be pooled with this storage through the SCM vehicle. So if you ran out and you needed more than 48 terabytes of storage, 46 or 44, 46. I'm fumble here, sorry. Now I can take unlimited amounts of IP-SAN expansion, and it'll all be presented through the SCVM as a single giant pool of available data. So you can increase your record times, you can increase the density of the cameras, you can add more NVRs, again going through a single vehicle that coordinates all of this storage. Single point of management. In addition to that, we give you the ability of using pre-existing storage. What was a high-speed vehicle of storage of choice prior to iSCSI and IP-SAN? It was Fiber Channel. That storage has value. It performs adequately for the video arena. You can take that storage that was connected directly to multitudes of other servers and add in a fiber channel HBA into the Falcon USS and keep your investment that you have in fiber channel storage from years before. So and not only is it a consolidation of pool resources that's inexpensively expanded via IPSAN, you can also preserve pre-existing investments in storage. All right, I want to go back to that question I had earlier where the question was raised, why do I, if I'm in a high availability situation, why do I need to double my network traffic? Most specifically your iSCSI and IPSAN traffic. The VirtualOS gives you the ability to fail over from one server to another server at an application level, specifically a VMS. Now, a lot of VMS applications have the ability to fail over to another server automatically. That's great, but there are a number of applications that do not have that ability to do that. So the VirtualOS, the Falcon USS, gives you the ability to fail over applications from one server to the other almost seamlessly. You might see a small, 5-second glitch as you move over, as you do a failover process. You might get a small period where your camera traffic is going to be suspended and lost, but it's very minimal, and the ability to do this gives you the ability to sell the products you've always been selling and meet that requirement that comes up for high availability. Right? Now, why do you need double the network? This server sits over here in a passive situation. It has its own internally held storage. This one has its own internally held storage. So anything that writes here from the cameras has to be also written over that network, right? So what happens is we're increasing. If you went from nothing to 100%, you've obviously taxed this, but this is ongoing all the time, all right? And so when you do a failover and you start to do a fallback when this unit is restored, this unit, when it's restored, is going to be handling the network camera traffic, writing it. It's going to be coming in through the NIC port process through this guest OS and going over here. And at the same time, you need to restore that net change data, the data that was written over here while the primary was down. So at that same time, you're going to be coming back across over into here and writing to the storage. That's why I said you have to allow it for a doubling of traffic. There's going to be a catch-up period from the secondary to the primary for the time that it was down. It's important to remember that if you're running in an HA environment, you've got to catch the primary back up while it's also taking camera feeds. There's only so much a subsystem can do. Everybody, again, has a ceiling of performance. Okay? Now, when you do a failover, okay, and we lost our product, automatically the two systems are kind of talking to each other and pinging each other, how you doing? Are your resources still good on the secondary? And the secondary is looking at this and saying, are you still running okay? So it's a two-way. What happens is when the primary goes down completely, the secondary recognizes the primary went down and it takes over. Its disk storage is current, and it's application aware of all of the settings, NIC port, traffic settings, and everything else. It will take over all of the applications, and its data is current because it's been essentially shadowed the entire time. The other way that you can fail over is the virtual operating system on the primary can recognize that it's having problems, and it will start the failover to the secondary as a last resort. If it can't fix the problem, it's going to say, I'm not performing as I'm required to do. I'm going to fail over to the secondary and let them take over. And you'll get customary notifications and so forth that there's something wrong. Okay. So you use the Falcon USS HA for VMSs and applications that don't have failover capability. The VOS mirrors storage data. It monitors health. Okay, this situation is best used with lower camera counts or multiple environments or with lower storage counts. If you're running 128 cameras, 256 cameras, and you need 96 terabytes of data, you would be better served to look at our VME and our IP SAN storage as a solution where you apply multiple modules, you maximize the camera support or application support per VME or module, and you share common data across the IP SAN, and it's singular. You alleviate yourself of the shadowing condition that's there, so it's a lot more efficient, and generally speaking, our IP SAN storage products are higher performing than the performance that you'll get out of storage that's embedded. But again, not to detract from the Falcon USS, it's a great product and it fits this segment that wasn't addressed before. But as you move up the food chain, you know, as is the case with anything, you have different metrics that you apply for the solution. And I believe I am at my favorite part, questions in general. Through this whole thing, does anybody have any questions that they'd like to ask at this point? I'm getting crickets here, guys. Somebody, give me something fun and challenging.
Yeah, I do have one that just popped up. Dick, hang on a second. Let me read through it here. How can the advanced features be used on the USS?
Oh, okay. Let's go back. We'll talk here so I can draw it in a little bit. Some of the advanced features in the security environment aren't germane. Snapshots, for instance, are used for point-in-time recoveries or recoverables. But one of the things that we have come up all the time is they have fringe application where they have a number of NVRs, what we would call Falcons, or we could apply the Falcon USS in different remote locations, and they want to be able to back up to a central location. Now, they don't want to use the backup or archiving capabilities of the software. They strictly want to move the data to a central location so that it's safe. Our replication, which infers asynchronous and remote, allows this vehicle to automatically, the SCVM will coordinate this with the correct license. It will take any of the data that's stored in here or here or here and replicate it at a byte level, bit for byte, at a block level from wherever the data physically resides out across the network and over into an ISC product. So we can again, leverage our other product resources and create an independent backup. Now, in the event that you had a catastrophe, you would be able to restore this data back into the pool once this machine or the data problem or disaster that happened, we're able to restore it back. So that's a good example of why replication is good. Second one is, let's take the same drawing, only it's going to be local. All right, let's make it an L for local, so we'll remember this. Mirroring, which is standard in the SCVM, allows, again, these storage pools to be mirrored in real time to this storage. So in the event that something happened here, right, what we could do is redirect, the SCVM can redirect the storage. It's a manual process, but you would say, well, remember that storage that used to be over here? I want you now to get that, I want you to continue writing, but I want you to write it to this vehicle. And all of you client viewing people, and you needed to go back and look at yesterday, it's here. So look for it over here. So we can use local mirroring as a pseudo high availability storage environment, or we can use it for a backup without consuming any backup resources within the Falcon USS.
Great, thank you. I do have another question that came in. Read it word for word here. If a particular VMS cannot use all of the processing power in the system, say 8 or 12 cores, would you recommend using a virtualized platform?
Okay. Okay, so is this was that using singularly a single application, or multiple applications couldn't use all of it?
Singular.
Okay. If it was a singular application and it couldn't use all of the, I'll answer it two ways. If it's a single application and it doesn't use all of the server's capabilities, the first thing you would call to question is, can I reduce the processing power, memory resources, to give me a better fit? And if it's a significant amount of storage that's or power available, then you might want to look and see, can I take advantage? If you don't have a multiple application requirement, no, don't virtualize your machine. But if you recognize that your CPU is very undertasked and you're buying and using other services for other things, then yes, call to question, can I move these products over into my virtual Falcon USS environment? That's the big thing, is if you have other things that you could move over and take advantage of the power that's being used there, or go ahead. The question you really have to ask yourself at that point is, do I really need to do that? These servers are already in place. I already own these machines, and they're working fine. Now, if they were getting long in the tooth, they weren't meeting your requirements, you had an expansion requirement that couldn't be met by those, again, yeah, swing over, virtualize it. So I'll give you guys two answers there. I hope that helped.
Great, thank you. And I have one final question, just to clarify. Can I also use your solution as the primary solution for all server requirements and storage? So instead of having a server for video, security, access, and so on, I can use the Falcon USS?
Read that one to me again.
Sure. Can I also use your solution as the primary solution for all server requirements and storage instead of having a server for video, security, access?
Oh, yes, that's the intent of the Falcon USS, and the what you get by virtualizing is, yeah, you can use it as the primary, but again, always be cognizant that virtualization isn't the answer. It still has wrappers around it. There's only so much power you can apply within there. So if you want to have a primary and you want to bump it up in processors and memory so that it can do everything in one box instead of multiple servers, yeah, that's exactly what this thing's for.
Great, thank you. I think that's it from this side.
All righty, well, thank you very much. And again, please use myself. Just call your sales rep. He can connect me up. If he's not available, ask for me specifically. If I'm not available, we do have other support engineers there that will be glad to take your questions and help you with your with what you want to accomplish. So thank you for taking time, and Ted, thank you again for being my wingman.